So we calculate indefinite integrals. What we are looking for is the derivative. So, right, we are undoing the derivative. So capital F is an antiderivative of little f if f prime, big F prime of x equals little f prime of x. In other words, looking at what we do is we ask ourselves, what function big F has little f as its derivative? So for example, if little f is cosine x, what function has f? Do we differentiate to get to cosine x? Exactly. So sine x. So f of x, capital F of x, sine x, this is the antiderivative of cosine x because of sine. Now, when you do indefinite integrals, these antiderivatives, right, these things here, doing the same thing, what we want to do, right, so this function f of x will sine of x, the sine of x plus 6, that also has cosine x as its derivative because the derivative of the constant is 0, right? Our whole thing is cosine x as its derivative, but the big part is it has sine x, right? And then plus an arbitrary constant. So this plus c is the arbitrary constant. Now, if you're online homework, sometimes the programs that you use will add the plus c, and sometimes you'll be required to have a plus c on there. So look at the end, maybe it's already included. If not, go ahead and add it in. All right, some derivatives memorize because that's just how you do it, and others, they will have rules to follow. And really, there's only one rule that we're going to look at right now, and that's the power rule. So if we integrate x to the n dx, so n over negative 1, what the rule is to find the antiderivative. And if you might imagine, right, this is the antiderivative. We're doing the opposite of what we did for derivative. So it should sort of feel like, oh, add 1 to the power and divide by the new power. And then always plus c. Okay? So if you're integrating, right, an x to a power, and 1 by, so here we go. We'll integrate x squared plus 3x. Notice it doesn't have any limits of integration. That shows us we're finding our indefinite integral. So x squared plus 3x. So using our power, we're going to 2, and then we divide by the new power. Okay. Plus, we're going to do the same thing here. So the 3 tags along, x, its current power is 1. Add 1 to that to get 2 into power. Now, what if it's a fraction? It works for all n except for negative 1. So here we go. We're going to add 1 to that, x to the 3 halves. So 1 half plus 1 is 3 halves. Divide 3 halves. See, I forgot already. So plus c. Remember your plus c right there. Plus c. And then this right here, I want to show you what I actually do. So, right, we're dividing by a fraction. I'll show you up here so that you're convinced. So x to the 3 halves divided by 3 halves. So when you divide by a fraction, right, that second one flips and multiplies. So what this really is equal to is 2/3 x. I see to rework this. So we're just going to do the antiderivative. So x to the, I'll do a different one, x to the 1/3 dx. Okay. X to, so 1/3 is the old power, add 1 to a 4th, divide 4, but then the thirds pops up to the top. Okay. So I'm not going to go through this step because I've done it enough, and if you convince yourself, right, when you divide by that new power, the fraction stays, they're actually, okay, last one. I'm integrating 1 over x to the 6 dx. So I need to make that look like a power. So x to the, right, so if we bring it up, makes it a negative 6. 1 plus is negative 5, and then divide by the new power. Right? Yes, and of course, there are many ways you could write that. Right, negative 1 over x to the 5th plus c, probably the most. Okay, our power. And now we have some that we're just going to memorize. Okay? So if we're integrating 1 over x dx, what that equals is the natural log of the absolute value. Okay, right, so, and if you get stuck, it's like, I can never remember which way it goes. So if we write 1 over x dx as x to the negative 1 and find its antiderivative using the rule, we add 1, 0, and by 0, there's the issue. So we can't divide by 0. So that's how we know it's not the power rule, and it's the special case. Okay, integrating e to the kx dx. This equals 1 over kx plus, if we integrate sine of kx dx, this equals 1 over k negative cosine of kx plus c. if we cosine x, so now we have a coefficient. So k is just a coefficient in there. So this is 1 over k sine kx plus c. Notice the argument stays the same. Even when you're integrating, when you're different, if you use the argument of a trig function, right, you're going to have to come up with a rule or some sort of right, property that lets you do that. So this one, this is just a constant with respect to x. This equals k times x. And then, of course, plus c. So if we wanted to practice something, right, so I want to integrate 2x dx. The rule says that this would be 1/2 e to the 2x plus c. Again, right, the argument stays the same. I want to integrate the sine of 3x dx. Okay. So that's going to be negative 1/3 cosine 3x plus c. Rules. I have a hard time remembering which one gets the negative sign. So I will always have written down somewhere, it's my little cheat sheet, this little device. So sine, cosine, negative sign, negative sign. So going this way is integrating. Okay. So the integral, the antiderivative of sine is negative cosine. Antiderivative of cosine goes to sine, negative sign goes to cosine goes to sine, back around to negative cosine.